Section 4.2, looking at reflections as our new type of transformation. Our essential question, how can you reflect a figure in a coordinate plane? Reflection is a transformation that uses a line, like a mirror, to reflect a figure. A line of reflection is the mirror line for the reflection. So there's a couple different things based on how we're doing what our line of reflection is that we do. Okay, and that's what we're going to look at. So there's some ways that you can do it. There's also some rules. So we're going to start off looking at example 1 and 2 on a process. We'll then look at, example 3, we'll look at a different process, another process, and then we'll look at rules that we can use to apply to those. So example 1 says the vertices of triangle ABC are 5, 3, 6, 10, and 10, 4 for A, B, and C. Graph the reflection of the triangle ABC as described below. So if you notice on both A and B, we have the black image there. That is ABC. That is my original picture. That's my pre-image. Okay. Then A says reflect across the x-axis. So I have this line here. Okay. So the red here is my image. And the way I got that is I count it down to the line of reflection, and then I count that same amount across. Okay, so I'm counting to the reflection and across. And that gets me my points. B, the y-axis, so this is my vertical y-axis here. I'm doing the same thing. I'm counting to the y-axis, and I'm counting that same distance across. So if I look at C on both of these, on A, I'm counting down 1, 2, 3, 4. So then I count down 1, 2, 3, 4, and get my C prime. Here I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to get my C prime. And the number is going to be different for each letter, okay, but it's the same distance from the axis. Example 2 gives us triangle ABC. A is -1, -1. B, -5, -1. C, -8, -5. So again, in both of these, I have my original pre-image. Okay. A says x equals 3. So now realize, this is my x-axis. X equals 3 is this line here. Okay, because at all of those points, x is equal to 3. People will get confused with the x-axis and then x equals. So x equals is a vertical line because my x-axis is horizontal. Right? And then I do the same thing we were doing before. I count over from each part. So B, y equals 1. Right? I come up 1. I graph this line. That's my y equals 1. So I'm counting to that line and then counting above that line. None of these show this. Realize if you could have a picture that goes on both sides, and then you would count one direction for one and go up and count the other direction for the other. The other thing we will see is y equals x and y equals -x, okay, which is the top part here. Right now we showed this with a line. So y equals x goes this way. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. That's my y equals x. If I look here, y equals -x. So 1, -1, or actually -1, 1, -2, 2, -3, 3. Coming down this one, 1, -1, 2, -1, 3, -1. Okay. I generally find on this, the rule, we'll talk about it in a second, easier, but I can do this with counting. If I'm counting from F here, I count to my line. So I'm going to count down. Okay, and I come down 1, 2, 3, 4, 5, 6, 7, 8, 9. So that I would count over, I'd turn 90 degrees and count over that same amount. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so G, count down and then over. You could also count over this way and then down, but you're turning at 90 degrees when you're doing that. Same thing with y equals negative x. I count to my line. So if I count up, I come 1, 2, 3, 4, 5, 6 up. 1, 2, 3, 4, 5, 6 over. So then the rules, okay, reflected in the x-axis, right? I start at AB. I now have A, negative B, which means the sign of my B coordinate changes. In the y-axis, I have negative A, B, meaning the sign of my X changes. Right? The reflected in the YX, I have BA, so I switch where they are. And then Y equals negative X, I do that same thing, I flip them, but I change my signs. I have negative B, negative A. So I'm going to go back to our previous problems and show these rules. So example 1, right, we're reflecting across the x-axis. So I have 5, 3. My new A is 5, negative 3. I changed the sign of the Y. Right? I went from 6, 10 to 6, negative 10. Went from 10, 4 to 10, negative 4. Now if one of those was already negative, it would become positive. So it's not making it negative, it's changing the sign. The y-axis, right, we're changing the value of the x. So 5, 3 becomes negative 5, 3. 6, 10 becomes negative 6, 10. 10, 4 becomes negative 10, 4. You can relate this to how the across the axis works, but it's slightly different, that you need to take into account that you're not actually at the axis, you're 3 away. Right, so I'm changing the sign, so this A would change from negative 1 to positive 1, and then I'd have to take into account this difference here, right, which is why you end up over here. So example 2, that type of thing I generally find easier to count. Right. Then if we come back to our top here, right, we had F was negative 8, 2, so we flipped that, 2, negative 8. G was 1, 2, so we flipped that, 2, 1. When we do Y equals negative X, negative 8, 2, I flip them and change the sign. So the positive 2 goes to the front and becomes negative 2. The negative 8 goes to the back and becomes negative 8. 1, 2, I flip it, 2, 1. And then I change the sign. So I have negative 2, negative 1. Then another thing related to our mirror line is the line of symmetry, or line symmetry. So line symmetry is a figure that can be mapped onto itself by a reflection. The line of symmetry is the reflection line for the symmetry, which is very similar to what we were looking at with our line of reflection. So we look here, it says that determine the number of lines of symmetry. So here we have 6 lines of symmetry. We have the lines going through each connecting corners, right? And there's 6 lines of symmetry there. In example 2, or in the second one, we have 2 lines of symmetry. These 2 lines. The lines coming diagonal don't work. If you fold over, okay, that would not match up. So a lot of people want to say 4 here and use these 2, but those 2 do not work, because if I fold it over, this corner doesn't match with this corner when I fold it over. Okay. Then our star here for the third one, we have 5 lines of symmetry. The next thing we look at is rotation, and the lines of symmetry also match up with some of our rotational rules. So we'll talk about that. If you have trouble seeing the lines of reflection, the rotation might help you see that. And then we have our last term here, our glide reflection. A glide reflection is just a translation, also known as a slide, followed by a reflection. Okay. So, my stuff got a little bit messed up here. They give us triangle ABC, -1, 4, 2, -1, 4, 3. Okay, so that's the black original image there. Okay, then they ask us to translate it using the rule. So the +2 -1 is for A, the -3 +1 is for the B. Okay, and then this asks us to reflect in y equals x for A and reflect in y equals -x for B. Right, and it says graph ABC and its image after the glide reflection. So that means you need the first and the third. Okay, so the first one here, A, I showed all 3 because if I'm counting, sometimes that's easier. So I did that, and then I count over and do my reflection. But you can also do that with the points. So this gives me the original. My A prime is 1, 3 because I added 2 and subtracted 1. My B prime is 4, -2. My C prime is 6, 2. So then when I do the reflection, y equals x, I'm switching those. I get 3, 1, -2, 4, and 2, 6. That's my image here. Okay. Similar concept here. I have -3 + 1. So I'm back at this original image. I subtract 3 and add 1. That gives me -4, 5, -1, 0, and 1, 4. And then when I reflect that, y equals -x, we're flipping them and changing the signs. So I get -5, 4 as A double prime, 0, 1 as B prime, or B double prime, and -4, -1 as C double prime. So then I graph those points.